So we're going to start off by the talk, Doing It the Hard Way, Improving Observability from the Bottom Up by Eric Delinsky.
Hey, my name's Eric. I'm a software engineer at Sauce Labs, and today I'm going to talk a little bit about how we improved our observability the hard way. This is what our monitoring looked like about a year and a half ago. And no, this is not during an outage. It was just this unreliable. We ended up having to, once a day, go in and restart all the services just to keep it alive. And in the process, we lose about 6 hours of data. At the same time, my team realized that we needed to double down on improving our observability. We knew that some other teams had started using Prometheus, but we needed to use it at a scale that they just weren't at yet. So we came up with a master plan. We were going to build our own monitoring platform from scratch with no previous experience. We were going to use this platform to improve our observability at scale. And just by having this platform, all of the other teams in the company are going to immediately start using it and love it. Obviously, this is a little bit short-sighted, but it put us on a road of learning some new things. And I learned 4 main lessons out of this that I'm going to talk about today. The first of which is make it worth it. So part of the premise is that we need to make this new platform better than anything anybody else is using within the company. So that really boils down to a bunch of different features. Things like having HA Prometheus deployments, decentralized scrape and rule configuration, having Prometheus be horizontally scalable but with a single query endpoint, and having long-term storage. This basically boils down to using Prometheus Operator and Thanos or Cortex. We use Thanos, but there were also some features that we just weren't using before in our existing stack. So having a single sign-on for Grafana, upgrading our Slack notification templates, and being able to have alert-driven tickets and chat annotations have been really useful, especially recently, to improve our workflow. On top of features, you also have to lower the barriers to entry. And this really came up when we were talking about how to scale our platform. We wanted each team to have control of their own Prometheus instance. So we were going to shard a Prometheus instances by owner. And that introduces a new problem in that you have to teach a team how to run their own Prometheus instance and how to deploy it and how to configure it. Luckily, we came over that problem using GitLab pipelines and automation. So in our deployment, we have a 2-stage 2 repo pipeline. In the upstream repo, you define all your configuration for a particular Prometheus instance. And in the downstream pipeline, we have common configuration for each environment. The result is that it's really, really simple for a team to spin up their own Prometheus instance. All the configuration that they need is shown on the right side of the screen. And through the magic of Helm, we overlay the upstream configuration on the downstream configuration before deploying it. The next lesson is implementation over standardization. We can leverage that pipeline to introduce common configuration and make sure that teams are following the standard that we've set out, but we don't have to police teams into following the standard. The standard is built into the implementation of the Prometheus deployment. So things like alerting endpoints and the Prometheus version and Thanos sidecar config, as well as external labels and environment-specific configuration are all configured in the downstream pipeline. And by having the Helm values overlay on top of those, we make sure that teams are following the standard while still allowing them the freedom that they need in configuring their own Prometheus instances. And the last lesson is that sharing is caring. One of the core shortfalls of our initial plan was that we were just going to build this thing and everybody was going to come. We tried that for a while and it didn't really work out well. We didn't end up improving our own observability or the observability of other teams in the process. So really simple things like having a Q&A Slack channel where people can ask questions about how to improve their own observability, or good documentation so that when you do get asked questions that you can reference documentation and don't have to repeat yourself every time. I also like to tail team Slack channels and inject myself into conversations where I think there's an opportunity that the team can improve their observability. And the running joke is there's an exporter for that. But there's also a lot of really good content out there on the web, from PromCon, from GrafanaCon, KubeCon, as well as a bunch of blog posts that are really useful when teams are learning to improve their observability. And of course, demos. Demos allow us to share the cool things that we're doing, and that can help inspire teams to improve their own observability. So in summary, make it worth it, lower barriers to entry, favor implementation over standardization, and of course, sharing is caring. Thanks so much. Have a great con.
Okay, thank you. So the next talk is from Jin-Woon Kim, and it's on conceptual architecture for tracking and rollback releases based on metrics.
Hi, my name is Jino. The topic of this lightning talk is to introduce metric ops concept architecture with the deployment and rollback based on metrics. I joined Nextcloud in this year. I'm currently in charge of product owner called NextClipper and NextClipper open source. I'd like to learn all kinds of things related to cloud native platform and ecosystems. First, I'm going to talk about today is the GitOps and the SLO. Next, I'm going to explain metric ops, CI/CD architecture that you are not familiar with metric ops, but you can think of as a concept architecture simply today. GitOps is a way to do Kubernetes cluster management and application delivery. Deployment in a single way from a single source, as also known as SSOT. A key part of GitOps is the idea of environment as code, describing your deployment declaratively using YAML file stored in a Git repository. Automated delivery pipeline for desired system state. As you know, SLOs can give you a concise and low noise signal as to the overall health of your service or system. SLO must be accurately measured and displayed using a monitoring system such as Prometheus. Typically, applications are deployed declaratively in the following GitOps style. First, we deploy a Flask application and monitor it with an existing defined alert loop. I deploy a new version of the Flask application, but internal server error is detected and firing, and send the notification. So, Ops manager in charge of try to roll back on his home or go back office. So, Ops manager roll back to previous version. This scenario is a common scenario. Next scenario I call metric ops. We are going to deploy same application to the Kubernetes cluster, but we are going to have a webhook of sidecars for injection. When the application is deployed, a set of apps called metric ops pipeline is prepared in advance. And to monitor, we create rules through PromCon or PromCat.io. We are building a solution is export hub. Exporter catalog is to add alert load at the Prometheus instance. When the application is deployed, the sidecar is injected and the sidecar call API to store image tag, timestamp, label, alert load information on the metric ops pipeline. Then when application version is updated, the related metric ops pipeline information will be updated. Image version is 1.1. However, if 500 internal sub error, occur in the same way. The controller check the firing state and notification. The request rollback command controller rollback to Kube API. The application rollback with the existing version. Metric ops can be not a nice idea, but through simple idea. I hope the people who say this today and our customer will get the value. Thank you for listening to my presentation so far. If you have any question, feel free to contact me and question below channel. Thank you.
So our third lightning talk today is from John Winton about AWS Private Link for easier multi-account monitoring.
My name is John Winton, and I'm a DevOps engineer at Button, a mobile e-commerce company based in New York. Today, I'm talking about an AWS networking tool called Private Link. This is going to be quick, and we'll use a lot of AWS terminology, so if you're not familiar with any of these tools, check out the docs on the AWS website. Let's get started. Let's say you have a single account running some set of applications, and Prometheus is monitoring those applications. A VPC stands for a virtual private cloud, and it's just your corner of the AWS cloud where you can launch your compute resources. It's simple now, but as time goes on, complexity increases. Say your data team comes to you and says they want to start running their own services in their own VPC for some network isolation. Great. They also need to monitor their services, so you follow best practices and drop a Prometheus instance in their new data VPC. But you realize you should probably take advantage of the alert manager you already have running in your core VPC, since it has all your alerting and inhibition rules. So you peer your VPCs. Peering just allows network connectivity across a certain IP range that you control. But we get even more complex. Your environment matures and you start to realize it would be much easier to control access if you could use multiple accounts. So you spin up another account, and now you have an AWS organization. You still need to get alerts from your new account to your old alert manager, so what do? I made this slide a little more obtuse than it needs to be to illustrate a point. We can definitely peer the tools VPC with the core VPC and route alerts to our original alert manager, and this is a common network topology pattern. But I want to take this time to discuss another option, Private Link. If you've heard of VPC endpoints, you're kind of familiar with Private Link. VPC endpoints enable users to connect to AWS services, like S3, that are outside of a VPC through a private connection, or a private link. Now normally, if your servers in your VPC try and connect to S3, they'll make a request that goes out to the public internet and then back into AWS in order to find S3. A VPC endpoint provides direct connectivity to the S3 service, and it stays entirely within the AWS network. Now, here's the thing. Private Link lets you do the same thing, but with your services. So why is this better? Private Link is a direct line to a load balancer in front of your service, and you can authorize any account to connect to the load balancer. These connections happen entirely within the AWS network, and since it's a direct connection to a load balancer, you don't need to peer VPCs or maintain blocks of IPs for authorized traffic. All you have to do is provision a network load balancer and you're good to go. Looking at the diagram on the right, I added some more complexity to the mix. Since we can cross account boundaries with Private Link, I moved Alert Manager into its own account and connected the new account to the Private Link interface endpoint. By adding Private Link to those other VPCs and leaning into account separation, we're able to create one centralized plane for alerting in our organization while keeping Prometheus local to each VPC. We can even take this pattern further to other types of observability. At Button, we've centralized our alerting plane along with our log aggregation. In this way, all of our application monitoring can be aggregated in a single place, which makes maintenance much easier. One thing to note here is that you shouldn't run Alert Manager behind a load balancer, since Prometheus needs to send an alert to all alert managers in the cluster. If we go to the docs, when you create a private link endpoint, a service must specify which availability zones it will run in. When you connect your account, say the tools account, to the private link service, you get a DNS entry for each availability zone the service is running in. And yes, you can assign your own private DNS entry to make it a lot easier to reason about, but this gives you direct connection to a single instance running in each availability zone. And finally, the only bit of code that I'll show, Button is a Terraform shop, so I've included the resource declaration for a private link endpoint service. As long as you have a network load balancer provisioned, you can quickly turn it into a private link endpoint service and pick which accounts you want to connect. Well, thanks for hanging out as we ran through Private Link. Hope you'll have a great rest of the day.
Okay, our final talk then today is by Ravi Hari about Prometheus for Remedy.
Hi, I'm Ravi Hari, staff software engineer at Intuit. Today we are going to talk about Prometheus for Remedy. So we'll look at a high-level agenda where Remedy fits in the Prometheus, and what are the use cases for it, and how can we implement a Remedy solution, what are the challenges and stuff like that, and how we can overcome them. So this is a high-level Prometheus architecture. Nowadays, Prometheus has become a de facto standard in Kubernetes monitoring, and it kind of pulls up data from various different sources, and Alert Manager kind of gets those metrics and validates against the alerts that we have defined. And if a particular criteria is met, it will kind of send the alerts through notification channels. The challenge here is that a human intervention is needed, for example, to pick up that alert and then kind of act upon that alert, because of which the mean time to recover can be high. Instead, if we know a particular pattern of scenario, we can implement a remedy solution for it, with which the recovery time for a given issue can be less. If you look into it, there can be a number of use cases for such scenarios, right? Example, a DNS pod can be in a bad state, and we can go ahead and delete it and ensure that it comes up fine. Or the CPU or memory in a given pod is high, we can go and delete those pods, and the new pods comes up clean. And in the backend, we can anyway troubleshoot why they went high. Or if a storage volume is high, say example in a Prometheus storage, we can kind of delete the old set of metrics that we don't need, or we know the metrics which have high cardinality, those can be deleted. So there can be a bunch of such use cases we can solve using a remedy solution. Now, how we can implement a remedy solution? There can be multiple ways. One such way is using a controller in Kubernetes, where we can define a remedy CR like this. Now, I'll quickly show an already run CR for this. So here we define the resource that we want to monitor. It's a pod, and we give it the definition for the analysis of what we want to monitor. Here we are looking for memory utilization, and then we give the threshold as 95%. If it crosses this 95%, we define the remedy action to delete that. Here we see that the pod is running now, and then once we launch this CR, after a certain time, the pod is not available. And if we look into why the pod is deleted, we see that remedy analysis says that the memory utilization is 9.48, whereas the threshold is 95. So it exceeded it, and the analysis check failed. So it went ahead and deleted based on the remedy action that we defined. So this is a very good use case, and now there can be any number of such use cases that we can custom define in the controller, but an end user might have a different scenario which we haven't thought of, and he might kind of struggle in bringing in his use case when we implement it with a controller. So and there can be a delay in order to implement his particular use case. Instead, we can solve this using Active Monitor, an open source Kiko project. Here we define a workflow that kind of does monitoring for us. And here, in case it is kind of looking out whether google.com is reachable inside a pod in a given namespace or not. So we can define a workflow like this for monitoring. And in order to have a remedy, we can also define a remedy workflow. And then with this remedy workflow, what we can do is we can go and remediate if in case actual monitoring fails for a given issue. And here the user can define what that remedy action could be. He can define to delete the pod, or he can define to do any other action, say, reduce the storage on the metrics and stuff like that. So it can give that ability for the user to define his custom remediation action. Now, the way it works in the Active Monitor for the remedy is that we define this workflow for the Active Monitor, both for the monitoring workflow as well as the remedy workflow, and the CR starts executing. It will pull the data from the Prometheus to see if a particular criteria is met or not. If a particular analysis check has failed, as we have seen in the example for memory, it will go ahead and execute the remedy workflow, and then it will rerun the CR. If in case if everything is working fine, it would go ahead and continue monitoring it. That's it. Thank you.